I'm entering yet another ranked coding contest. This is Leetcode's Leet Contest 472, and it starts in 1 minute. Man, I was reviewing the questions for the last contest. Boy, did I take the hard route for the second question. Apparently for the second question, you could have just brute forced it, but I went the recursion route with the horrible caching strategy. 3 seconds left. Contest started. 16,000 people. Okay, join now. Oh my goodness. Smallest missing multiple of k. So you're given a list of integers like this and a integer k, and you're supposed to return the smallest multiple of k that is not in the list over here. So I guess brute force, what we can do is figure out every multiple of k, like k times 1, k times 2, k times 3, etc. and keep checking the list. Is that multiple of k in there? If it's not, then return it. Yeah, that's basically the solution, right? Although we could do some optimization by maybe we can iterate over the list once and then store everything in the hash set first for a quick lookup. So we have O1 lookup time. I feel like that's it. That's totally it. And what's the constraints here? Num's length is less than or equal to 100. You can totally brute force this. Num's set form is equal to set of nums. M is equal to 1 at first, and then just while true, the next multiple is equal to k times m, and if the multiple is not in nums s, then return the multiple. Else m++, that's the thing you're multiplying k by, and then let's return -1 as a bogus value, but surely we're never going to reach that, right? Okay, run this thing. M++, there's no m++ in Python. This equals 1. Well, true, oh right. I keep forgetting this. Booleans are capitalized in Python. Cool. You know what? I'll submit this. Let's go! We got it. Heck yes. Okay, next problem. Longest balanced subarray. You're given a array like this. You're supposed to give the length of the longest balanced subarray, where the subarray contains the same number of distinct odd and even numbers. Let me guess, the output is really small. Yeah, the constraint is the list length is really small. Well, lesson learned from last time, that means brute forcing is okay. If brute forcing is allowed, we can totally go through every single subarray, right? So for every single, let's say we start from 2 and we go onwards, from 5 go onwards, 4 go onwards, 3 go onwards to the end, stuff like that, you know? Yeah, so for every I, we iterate that way, and then for every j, which is basically I to the end, we iterate. That's how we iterate through every single subarray. Okay, we need to track the number of even and odd numbers in here. I have a sneaking suspicion that we need to track it with sets. So for every single I, we should probably have like a set that stores what numbers are in here. Let's look at this example here. Maybe we have an even set or an odd set. Maybe we have a set for tracking the even numbers and then the odd numbers. So down here we will put 3 here, and then we put 2 here. We can totally input the next 2 over here into the set, and then it would just remain as 1 because sets automatically remove kits, right? And then 5 goes here, and then 4 goes here. At any point in time, we can compare the lengths of the 2 sets. If they're equal, then we have to return the length of the current subarray, which we have to be careful about that. We can't just add the lengths of the 2 sets here because the sets remove duplicates. We need to calculate the length of the sets by j minus I plus 1. So for I in range length of nums, and then for j in range I comma lane nums. So again, for every I, we need to store sets. So even will be equal to new set like that. Odd is equal to set like that. Okay, so for every new number we come across, we need to add it to the even or odd set. Let's do num is equal to nums j. That's the current number. So if num modulo 2 is equal to 0, meaning it's divisible by 2, then you put in the even set. Even dot add the current number, else odd dot add the current number. Yeah, and then at each position we need to check, are the lengths of the sets equal? If length of even is equal to the length of odd, then we need to update our best solution, right? Let's do best is equal to 0 for now. Our best solution then would be the max of the current best versus, so j minus I plus 1. And then at the end over here, you return your best solution. Let's try running this once. What's wrong with it? Invalid oh, I forgot the if in the if statement. We got it, I think. Screw it, I'll submit it. Let's go! We got it! We got 2 problems. I don't think I've ever solved the first 2 problems this fast before. This is awesome. Heck yes! Wow. Okay, place your bets, guys. Q3 has to be longest balanced subarray. Longest balanced subarray 2, right? I'm willing to bet money on that. Let's go. Oh, no. They juked us. Lexicographically smallest permutation greater than target. Okay, so for this problem, we're given a string S and another string target. We're trying to find the combination of S, meaning we can rearrange the letters, where it's alphabetically just bigger than the longest balanced subarray 2. Oh, this problem is kind of like second one, except let me guess, yes, the length of nums is unbounded, oh no. Okay, so this is like the last problem where you're given a array like this. You're supposed to give the length of the longest balanced subarray, where the subarray contains the same number of distinct odd and even numbers, but the difference is this time the input can be a lot, so no brute forcing, which is sad. Maybe we can do something where the even numbers will be +1, odd numbers -1. So over here will be -1, +1 is 0. Oh, what do we do about the... Dang it! What do we do about the repeated numbers? If it's repeated, maybe we can sort in a set somewhere of the seed numbers. So just 0 here, and then for odd we -1 again, and then for 4 we add again, so it's 0. Oh, so at this point in 4, we know that the number of odd and even numbers are the same. So we would immediately return 5. Yeah. And so these are all the cumulative sort of odd and even counts, right? If we see that we have the same numbers, like -1 and -1, that means this chunk over here, because -1, the cum counts between here and here inclusively is equal to the cum count ending here and minus this cum count, which is equal to 0. Oh, so we can probably store a hash map. So we store a hash map of the numbers we've seen, and we also store a cum count of like the cum sum and the first index where we've seen them. Yeah, this should be the algorithm, right? And then maybe we can start with 0 map to -1, something like that. So automatically we can do like, oh, 0, we've seen this at -1, so 0, 1, 2, 3, 4, 4 minus -1 is 5, so we return 5. I think we got it, boys. This is how you do it, right? Or am I getting overconfident here? Is this the first time we're going to solve a hard problem? I don't know. The fact that I think it's so easy should ring alarm bells everywhere, shouldn't it? Hey, okay. Time is up. Let's check out our scores. How do we check that? I'm rank 4,927. Oh, we can check answers now. How did people do question 4? Oh my goodness, this is so long. Bro, he defined 3 helper functions. What did people do for lexicographical? Oh, my eyes, it hurts. Why is this so long? I will have to check the solutions later when my brain is not in so much pain as it is now.